Chapter 9.5, the binomial theorem. We're going to use the binomial theorem to find the binomial coefficients, use Pascal's triangle to find binomial coefficients, and then also to write binomial expansions. So the binomial theorem, so for expanding x plus y to the n, so notice that the coefficient of xn minus ryr is this here. So ncr, so n factorial over n minus r factorial, and then times r factorial. And then sometimes the symbol nr is often used in place of ncr to denote binomial coefficients. So we're going to find binomial coefficients using the formula from above. And so we just plug it in and solve. So we have 8 factorial over 8 minus 2 factorial times 2 factorial. So this is 8 factorial over 8 minus 2, which is 6 factorial, 2 factorial. Now a short way to do this is 8 times 7 times 6 factorial over 6 factorial times 2 times 1. And so I just write, the last number that goes to this value here, and it cancels out. And then reduce when you can. So 2 goes into 8 4 times. So the answer is 28. So 10, we're choosing 3 out of the 10. So 10 factorial out of 10 minus 3 factorial times 3 factorial. That's 10 factorial over 7 factorial times 3 factorial. So 10, 9, 8 times 7 factorial, and then 7 factorial times 3 times 2 times 1. So 3 goes into 9 3 times, 2 goes into 8 4 times. So we're looking at 12 times 10, which is 120. So we'll try this one. 7, we're not choosing any. So we have 7 factorial over 7 minus 0 factorial times 0 factorial. Remember that 0 factorial is 1. So it's 7 factorial over 7 factorial times 1. And so that answer is just 1. Now this one, we have 8 factorial, we're choosing all 8. So 8 factorial times 8 minus 8 factorial times 8 factorial. That becomes 8 factorial over 0 factorial times 8 factorial. And we notice that also becomes 1. So try out these examples up here. Find each binomial coefficient. So try this out. For the first one, you should have gotten 462. The second one is 36. And then you get 1 and 1 for the bottom 2. So we're going to do a little bit more, find each binomial coefficient, so a little bit more practice here. So again, you do the same thing, 7 factorial over 7 minus 3, which is 4 factorial times 3 factorial. So this becomes 7, 6, 5, 4 factorial over 4 factorial times 3 times 2 times 1. And then the 4 factorial cancels out, the 6 cancels out, so now we're left with 35. So we have 7 factorial over 7 minus 4 factorial times 4 factorial. So that's 7 factorial. 7 minus 4 is 3 factorial, and then times 4 factorial. So this is 7, 6, 5, 4 factorial over 3, 2, 1 times 4 factorial. And we find that we get the same exact answer here. So we get 35. And then 12, choosing 1. So 12 factorial over 12 minus 1 factorial times 1 factorial. That's 12 times 11 factorial over 11 factorial. And then times 1. And we find that the answer is 12. Here we have 12 factorial over 12 minus 11 factorial times 11 factorial. We get 12, 11 factorial times 1 factorial times 11 factorial. And we notice we get the same thing here. So just noticing the relationship that you're with the numbers that are chosen. So go ahead and try these 4 examples here. So if you tried this out, you should have gotten 21, 21, and 14, and 14. So in example 2, it's not a coincidence that the results in parts A and B are the same and that the results in parts C and D are the same. In general, it's true that n choose r equals n, choose n minus r for all integers r and n, where r is between 0 and n. So just notice that relationship there. Now let's take a look at Pascal's triangle. So remember with Pascal's triangle, how this works is that the first and the last values are 1. So the first and last numbers in each row are 1, and then each other number in a row is the sum of the two numbers immediately above it. So notice this, we have 1 and then 1, 1, and then down here we get another 1. 1 plus 1 is 2 here, right? And then over here to get the next row, it's 1 plus 2 is 3, 2 plus 1 is 3. Down here you write the 1, 1 plus 3 is 4, and so forth. And so there's a pattern with that. The other thing with this is that the first row is the 0 row because that is x plus y to the 0, which is 1. For the second row, that is x plus y squared, to the first power, and notice that's x plus y. When we go to the next row, it's x plus y squared, and we notice that's 1x squared plus 2xy plus 1y squared, and then it continues on. So the next row is x plus y cubed. Now we use these coefficients here, and it would be 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. And so the pattern continues on like that. And so what you notice is that the first term, it's the power here is the third power in the third row, and then that first value descends. So x cubed squared 1 and then 0, and then the y goes up. So it's y to the 0, y to the first, y to the second, and y to the third. There's many patterns to notice with this. Another thing to notice is that whatever row you're in, so in row 3, raised to the third power here, what you can look at is the exponents. The exponent should add to whatever row you're in. So x squared and y to the first, that's 3. And so that will kind of help you out when you're using Pascal's triangle and binomial expansion to make sure that you're applying the correct exponents to each one. So let's try using Pascal's triangle. Use the 7th row of Pascal's triangle to find the binomial coefficients. So we're going to use the 7th row, and then we're going to try to find this 8th row here. So in writing the 7th row, let's write 1, 7. So if we're looking at that sheet, we have 1, 7, 21, 35, 35, 21, 7, and 1. Now, we're trying to find the next value. So the next row would be 1. 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 35 is 70. And then 35 plus 21 is 56. 21 plus 7 is 28. 7 plus 1 is 8. And the last one is 1. So those are the binomial coefficients of each of these values here. We just use the row above it. Now use the 8th row, so the row that we just did, to find the coefficients for these values here. So rewrite this one below and then try to find the coefficients. All right, so if you tried it out, you should have gotten these values: 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1.